All right, so this is a new topic. It's called integration by parts. It just teaches you another cool technique, how to use, how to integrate more complicated functions. Uh, for example, something like this, x squared e to the power of x dx. You can't use u substitution. It's just not going to work. Or e to the power of x sine of x dx. Again, you can try the u substitution, but how's it going to help you? So you're going to get stuck, right? So when you have a combination of two functions and you see it's a product of two functions, then you can actually, and if you can't apply the u substitution or anything else, you can actually try this interesting rule that we call the integration by parts. Before I give you the formula, I just want to derive quickly, so maybe that would help you to memorize the formula. So let's say we consider the two continuous functions u and v. Okay, so how do you find the product of u times v prime? So you do, I don't need to explain much, you understand that you're supposed to do u prime v plus u v prime, right? Nothing new. Okay, now I'm going to rewrite it. So this is my function, I'm going to call it y. So therefore, dy dx, that just means the derivative of our function y, which is u times v, equals, now instead of u prime, I want to make it fancy, so I'm going to put du dx times v plus u, and instead of this guy right here, I'm going to put dv dx, which means the derivative of v. Now if you noticed, we can actually cross this out, and we end up with dy equals excuse me, I'm going to put v first, du plus u dv, right? So look at this now. I'm going to integrate both sides. So I'm just going to do this. Okay, now integral of dy, well, you have this invisible y here. We're skipping this plus c side, the plus c part, okay? So integral of dy is just y. Now let's skip this. Now I'm going to rewrite it a little bit differently. So I'm going to say integral of u, you know what, let me just do this. I'll just try to fit it here. So we get y. I'm going to move this guy to the left, and I get integral of u dv, and equals, and whatever we have left on the right side. So I'm going to rewrite it again. What was our y? The y was the product of u and v, right? So u times v minus u dv equals integral of v du. So believe it or not, I know it looks complicated right now, but it's not really that hard. So this represents the integration by parts formula. So this is a formula that we use to integrate by parts. Now I'm going to rewrite it, make it look a little bit easier. So integral of u dv equals uv minus, and then it alternates, integral of v du. Okay, now let's apply this formula to different problems. So for example, how would we integrate x cosine of x. Okay, the u substitution definitely is not going to work. So that means we're going to apply the integration by parts rule. So the question is, which one is u? Which one is v? So you have to assign new variables, u and v, right? So the students always have a hard time to decide which one is u and which one is v. And I'll tell you in a second. But in this case, I would say I'm going to actually express x as u and cosine of x v prime. By the way, this part right here, dv, is the same as v prime, right? And du is the same as u prime. So if you want, you can always express it like this: u v prime equals uv minus v u prime. Maybe it's actually easier. Okay, now, since I expressed u, I'm going to replace x with u and v prime, so you have to write it on the side. It always helps. Cosine x dx. Obviously, you include the part dx because this represents the derivative of v. That's one whole thing. So now, let's find u prime. So u prime equals to 1, right? So it's 1. And v, so if the derivative, if cosine, so basically you're looking for the integral of cosine. So that would be sine of x, right? Okay, now we're going to apply this formula, and we say this equals u times v. So which one is u and which one is v? So that's u and that's v. You can always circle it. U times v, so it's x times sine of x, minus integral, now it says, look at this, v u prime. So before you had u v prime, now we're going to put v u prime. So v is sine of x, and u prime is 1. You don't really want to put 1. By the way, 1 dx. When you find the derivative, you always put dx. Okay, so now we can actually finish it by integrating this part right here. So what's integral of sine? It's negative cosine. And now you can put plus c. And that's your answer. So one more time. So the formula is u, I'm going to rewrite it again. Integral of u v prime equals uv minus integral, it alternates v u prime. So in order to use this formula, you need to assign these variables u and v. You need to decide which one is u, which one is v prime. So I used the simple one I expressed as u, more complicated one I expressed as v prime. And then you just go from there. So let me do another problem for you. Maybe you can try some of them by yourself. So number 2, integral of x times e to the power of x dx. Okay, so we need to decide which one is u, which one is v prime, because it starts, I'm going to put it here again, uv prime equals uv, oh, I'm sorry, just uv, minus integral v u prime. So again, this looks more simple, just x, so it's going to be my u, and v prime is going to be e to the power of x. I'm going to put it on the side. U is x, and v prime is e to the x. Don't forget dx. Therefore, u prime equals a 1, but put dx next to it. And since v prime equals e to the x, then v, the integral of e to the x, is the same thing, e to the x. So done. Now, we're going to use this formula right here. So it's u times v, and which one is u? That's that. And which one is v? That's that. So x times e to the x minus integral, and now it says vu prime. So v is this, e to the x, and u prime is dx. Now, it's very easy, because the integral of e to the x is the same function e to the x. And then don't forget to put plus the cupcake. So now I want to show you this trick. In order to choose which one is u and which one is v prime, so you need to follow this guideline. The u should be an expression that when its derivative is taken gets simpler. Sorry, I had to pause. So I said the u is always the expression that is easy to differentiate, and v prime is the expression you always put pick the expression that you can easily integrate. Okay, now I always, well, not just me, but a lot of actually calculus students and teachers use LIATE. If you memorize it, that's going to make your life easier. So if you choose, if you use this for choosing u, then you can integrate by parts easily. So check the integrand. Integrand is the expression in your integral for the following expressions in order: L, logarithmic; I, inverse trig; A, algebraic; T, trigonometric; and E, exponential. So in this order. So here's what I mean. Let's say we need to find integral x squared ln x dx. Now, we need to decide which one is u. I'm going to put the formula again. U v prime equals uv minus v u prime. So we need to decide which one is going to be u and which one is going to be v prime. So remember, u is the expression that you can differentiate easily. A v prime is the expression that you can integrate easily, right? So that means this one, I need to erase this, sorry. So which one is easy to integrate? This one. Which one is easy to differentiate? This one. So then I'm going to do this. This is going to be u, and this is going to be v prime. So I'm going to write here u equals ln x, and v prime equals x squared. You see right here, you always start with logarithmic expressions. So if you have in your integrand, if you have logs, that's what you choose for, you substitute for u. Okay, so therefore, u prime equals 1 over x dx, and v equals, so you integrate, it's x cubed over 3. Now we're going to put this together. So then, based on this formula, it's u times v. So it's this times this minus integral, and now it's vu prime. So v and u prime. And that's it. So we can actually simplify, and we get what? X squared on the top, and on the bottom it's 3, right? Yeah. So that would be 1/3 out, and then it's x cubed over 3 plus c. And the result is x cubed over 3 ln x minus x cubed over 9 plus c. We're good. Number 4. It says evaluate actually the following integral. The boundaries are given. Arc sine x dx, which is the same as sine inverse of x dx. Okay, so we don't really know what the inverse of what an integral of sine inverse is, so we need to apply the u substitution. Now, remember I told you. Actually, let me go back. So u, which one is u? So whatever comes first here, so we have log, we don't have log. Then it goes I, inverse trigonometric functions, and that's what we have here. So then automatically you say, this is your u, and that's your dx part, is your v prime. Well, dx is the same as 1 dx, correct? Okay, so I'm going to write on side, u is sine inverse, and v prime is dx. Therefore, u prime, what's the derivative of sine inverse? It's 1 over the square root 1 minus x squared dx. And v prime is equals to 1 dx, therefore v equals, what is it? Just x, right? Okay, so let's put it together. The formula says, based on that formula, sine inverse x dx equals uv, so u times v, so it's x times sine inverse, minus vu prime. So v would be that, and u prime would be that. I'm going to keep that. Now, this integral, don't get scared. You can solve it on the side. I'm going to use a different, I know it does get complicated, but you'll get used to it. On the side. Here I would use u substitution. 1 minus whatever looks more complicated equals u. Then du equals negative 2x dx. And that's what we have right here. So therefore x dx equals negative 1/2 du. Okay, so we get integral, new integral, 1 over integral of what's 1 minus x squared u. And what's x dx? We solved for x dx. It's negative 1/2 du. So that would be negative 1/2 integral of u to the power of negative 1/2 du. It's negative 1/2 u to the power of negative 1/2 plus 1 over 1/2, and that gives you negative. You flip it, looks like that, negative u to the power of 1/2. Let me just double check. Yeah, looks right. So therefore, that part equals to negative, and u is what? 1 minus x squared to the power of 1/2. Okay, so that means we're going to continue here. X sine inverse of x minus, and this integral we just solved, and we got that. So negative negative gives you positive. 1 minus x squared to the power of 1/2. Now, normally it's plus c, but they want us to solve it. Yeah, it's actually a definite integral, so the boundaries are given. Well, I don't really have time right now, and I'm sure you know how to do it. You just plug in 1, you plug in 0, subtract, and get your answer. I want to show you another example, and that's the only, I would say, complicated case where you have to use integration by parts, but twice. Okay, so remember this right here. So which one is going to be u? So it goes log, inverse, algebraic, trigonometric. So we have x squared and sine, right? So, or in other words, which one is easy to differentiate and which one is easy to integrate? Well, let's say this is u. It's easy to differentiate, and it becomes just 2x dx, so I like that. And this one is v prime. Okay, so on the side we're going to put u is x squared, v prime is sine x, dx, don't forget, it's derivative. So automatically you say u prime equals 2x dx, and v, when you integrate sine, what do you get? Negative cosine, right? So now the formula says it's uv minus integral v u prime. Okay, so that equals uv. So u is this, v is that. So let's put them together. Negative x squared cosine of x. Okay, minus vu prime, integral of vu prime. V is negative cosine, so automatically I'm going to change that to plus cosine x, and a u prime, vu prime. U prime is this, so I'm going to put 2x dx. So we get negative x squared cosine x plus, pull out the 2, and you just get x cosine x dx, or cosine x x dx. You see, again, this part right here involves another integration by parts because you can't use the regular u substitution. So then you say, all right, so let me just integrate this maybe separately again. I'm going to just do it here. So integral of x cosine x dx. So u would be this, easy to differentiate, and that's v prime. So u equals x, v prime equals cosine dx. Therefore, u prime equals 1, and v equals sine, because derivative of sine is cosine. Now that means we get u times v, so that would be x times sine minus integral vu prime, v u prime times 1 dx. Now that's easy to finish. It's x sine of x, and integral of sine is negative cosine. So that's what we got, and we're going to plug it into our expression here. So we get negative x squared cosine x plus 2, and we got x sine of x plus cosine of x. I can put plus c here, I mean, you can distribute the two now, or you can just leave it like this. It doesn't really matter.